All right. Good day, everyone. Today we're going to be looking at part 8 of this artificial intelligence course, but it's really part 2 of our history of artificial intelligence, as we're going to look at the history of AI from the 1970s up to the 2000s or the new millennia. All right, let's get started. All right, so let's start by looking first at the 1970s and the history of AI during this era. So, by the end of the 1950s and into the 1960s, AI had transformed from philosophical speculation into an active scientific discipline with real programs playing games, proving theorems, and learning from data. The field was brimming with optimism, though the harder challenges ahead would soon temper those expectations. So in the 1970s, specifically in 1974, computer scientist Marvin Minsky, who was from the Dartmouth Conference, wrote a book called A Framework for Representing Knowledge that led to the concept of the Minsky frame, or just frames, which is a data structure used to represent a situation. Frames help us understand new situations and understand context by comparing them to similar patterns. So you can see in the infographic there, a frame, that data structure represents something like a stereotypical situation, like being in a living room or going to a birthday party. It's really about understanding context. Also in 1974, Paul Werbos, who's an American social scientist, in a paper introduced the concept of backpropagation, which we've talked about in the first unit of this course. It's the concept of revisiting and adjusting weights that link neurons in a neural network to influence the output. So the backpropagation concept started in 1974. From 1974 to 1980, this is considered the first AI winter. So it's considered that due to the unreal expectations, the computational limitations of the time, and a lack of significant breakthroughs, led to a sharp reduction in research funding in artificial intelligence. Some landmark critical reports, notably the 1973 Lighthill Report in the United Kingdom, led to dramatic cuts in AI funding and AI research. So this is considered an AI winter. All right, so let's move our history now up to the 1980s and right through to the 1990s. So in the 1980s, after almost a decade of AI winter, by the 1980s, there was a renewed interest in developing what are called expert systems. These are programs designed to model human decision making. Thus, we bring in a new boom to AI development. And this is seen specifically in something called XCon, or Expert Configurator. This is a self-organizing piece of software that was put into place by the Digital Equipment Corporation, or the DEC, which later joined with computer maker Compaq and later still acquired by Hewlett Packard, or HP. XCon saved the Digital Equipment Corporation, the DEC, company around $25 million a year by automating computers with customer orders, and was one of the very first examples of an early AI system working with a business and being financially beneficial. In addition to those American universities, MIT and Stanford, the University of Toronto became relevant in AI when researcher and British Canadian Dr. Geoffrey Hinton advanced on the field of backpropagation and on the field of neural networks. So much so that he is now really being called the godfather of deep learning in artificial intelligence. Canada became a crucial hub in the global AI research community and continues to be so to this day. This includes computer scientists like Yoshua Bengio, who is a French Canadian, and Turing Award winner Richard Sutton, who is both American and Canadian, and is considered another godfather of deep learning and of reinforcement learning in AI, and both of whom worked and taught out of the University of Montreal and later the University of Alberta. So now we're going to advance from the late 1980s to the early 1990s, and we now enter the second AI winter. This is considered the second AI winter due to the limitations and high maintenance costs of those expert systems, combined with, again, decreased government funding towards AI research. However, one of the most important developments in AI was beginning in the 1990s without us knowing it: our data. So in the 1990s, the rise in the popularity of the internet to the general public, the widespread use, the affordability of being on the internet, the variety of computer technology from personal computers to gaming to portable electronics as they started to develop, all the way up to things like autonomous vehicles. These were all starting to explode in the 90s. And as we started sharing more and more data online, we began the new information age, or the rise of big data. This period also reintroduced and enhanced concepts like backpropagation through the development of the convolutional neural network, or the CNN, which we've examined in the first unit of this course, which meant we were now training AI to think like a human using problem-solving techniques, critical thinking, and what we might call common sense through semantic networks, neural nets, frame languages, and deep learning algorithms. In 1997, Feng Shui Hu, a Taiwanese American computer scientist, who I'm sure I got that name wrong, led a team at IBM to develop a supercomputer called Deep Blue, which defeated world chess champion Garry Kasparov in a highly publicized match, demonstrating the power of search algorithms and computational speed, and it's considered an AI milestone. Deep Blue would use brute force computation, analyzing up to 200 million possible chess positions. And this would lay the groundwork for IBM eventually building Watson in 2011, competing on the TV game show Jeopardy using natural language processing, and defeating Jeopardy champion and now host of Jeopardy, Ken Jennings. The focus of the field shifted meaningfully from hand-coded rules towards systems that could learn. They could learn from our data, support vector mechanics. Bayesian networks and other statistical approaches proved far more robust than expert systems. In 1997, IBM's speech recognition and language translation systems began incorporating statistical methods with much greater success. Speaking of success, robotics also took a leap forward. For example, in 1997, NASA's Mars Pathfinder included a degree of autonomous navigation as that robot moved around on Mars. All right, so now we're going to move into the 2000s specifically. So in the 2000s, at the dawn of the new millennium, we started with a lot of economic uncertainty, the dot-com crash, which shaped the viability of AI in business, but also a wave of new technology and even more data, which is now and was then and now considered the new oil in terms of the value of that data. In 2001, Minsky's concept of frames was designed to mimic human decision making and was reimagined by American statistician Leo Breiman as random forests. So if a decision tree represents a single decision structure, a single tree, for example, a picture of a bear or a picture of a fuzzy rock, whereas a random forest, the model is many trees of decisions. And if some of them, say 75%, call it a bear, and some of them, let's say 25%, call it a rock, majority rules, and it will be classified as a bear, not a rock. So my apologies there. In 2002, in robotics, the iRobot Roomba is released, bringing a form of AI robotics into consumers' homes around the world. Also in the early 2000s, the term semantic web was being used to describe the new internet, which included XML, or extendable markup language, and resource decision frameworks, RDF, which would organize the web using hidden labels and making more meaningful connections between the data on the internet and all other data on the internet. And English computer scientist Tim Berners-Lee, considered the inventor of the World Wide Web, called the semantic web a fundamental shift in the way we use the internet for business and for managing our daily lives. So the early 2000s, the internet, which was introduced to the general public in the 90s on a widespread scale, is really now taking a fundamental shift. Major internet companies and influences on the technology futures were founded, like Amazon in 1995, or Google 1998, Facebook 2004, YouTube in 2005, Instagram 2010, etc. And that explosion of big data now included text and images and videos, which is the bedrock of what AI is now. So by the early 2000s, machine learning was quietly powering things like spam filters, product recommendations, and even early search rankings. AI had began embedding itself in everyday life, even if few people knew it or even called it that. Well, that'll conclude part two, everybody, of the history of artificial intelligence. I hope you enjoyed it and have yourselves a great day.